Plants contain tens of thousands of different proteins. These allow the plant to harvest energy from the sun, to grow and develop, and to defend themselves from insects and disease. Each protein has a specific job in the cell. They are the workers that do all the jobs required for life. We aim to discover more about these proteins and how they work. We are interested in a kind of chemical switch found on many proteins that is called an SA cell group. Research into plant science is very important because without healthy plants, we have no food or air to breathe. We also need plants for medicine, energy, and useful materials. But how do we do what we do? Let's take a closer look at a scientific paper recently published by some researchers in the lab. This one paper represents 8 years of hard work by 7 people. This one figure represents 5 individual experiments. Each experiment takes one person 5 days, meaning that this one image represents more than a month of lab work for one person. Let's show you one of these experiments and give you a glimpse into a week in the life of a plant scientist. After 2 weeks of waiting for plants to grow, seedlings are harvested, frozen in liquid nitrogen and ground up into a powder. A buffer is then added, which helps to keep the proteins stable and make sure they don't break down. Next, we need to work out how much protein we have. To do this, we use a colour changing assay. The deeper the purple colour, the more protein you have. We measure the colour intensity using a machine called a spectrophotometer. Next, we add a chemical called hydroxylamine to the proteins, which removes the chemical switch from a protein. We use a centrifuge to spin the sample tubes very quickly. This brings everything together in the bottom of the tube. We use a vortexer to thoroughly mix the samples. We spent a lot of time opening, closing and labelling tubes. Then we add some tiny beads that will stick to the part of the protein where the chemical switch has been removed. After an hour, the beads are gently washed multiple times to remove any proteins that have not stuck to the beads. We then add a loading buffer and heat the samples to remove the protein from the beads. To isolate our protein of interest, we separate them by size on a thin gel by running an electric current through it. Small proteins move faster than larger proteins. The proteins are transferred onto a membrane, again by passing an electric current through it. After a few hours, the protein is transferred from the gel onto a membrane. We then add a red dye so that we can see it and check that it has transferred properly. The red dye is then washed off and the membrane is ready for the next step. Antibodies are then added to the membrane to bind to our protein of interest. These antibodies carry a special molecule that will emit light when we add a chemical mix. This can't be seen by eye, so we use an imager to show us where the proteins are.